Fusion Mobile, quality e-learning experience on the go.
Linear inequalities, do not let the term linear inequalities confuse you. Do not be confused by the phrase linear inequalities. It is still the same as the linear equations, okay? And the same process is used to solve the linear inequalities. The same process, the same procedure as we used for the linear equations. The only difference here is that inequalities are mathematical statements or mathematical expressions, okay, that seem to compare. They are mathematical statements that compare two expressions, okay. So there's comparison here. There's no equality. The equality sign does not hold in linear inequalities. Rather, we have such sign as less than, okay. We have greater than, we have less than or equal to, and then we have greater than or equal to. Now look very well at these symbols. Coming from the right, okay, the pointed end is less. So you say whatever is on the right, coming from the left, okay, the pointed end is small and then opens up to the right. So whatever is on the left side of this symbol is less than whatever is on the right of it. Do you understand? And whatever for the greater than this sign, you can see that the open end is greater than the pointed end, is wider than the pointed end. So whatever is on the left of this symbol is greater than whatever is on the right. Here there is another symbol that adds to the less than. Here another symbol adds to greater than, and that symbol, okay, is what gives it that meaning of equal to. Okay, so you have less than or equal to, greater than or equal to. So instead of using, for instance, when we had that equation that said 2x plus 6 equal to, now we can simply say, okay, 2x plus 6 less than 16. Okay, now we no longer use equal to, rather we use one of these symbols, and of course 2x less than 16 minus 6, 2x less than 10, x less than 10 over 5, x is less than 2. Now this is the way it works. It's just as simple as that. The same procedure, the same process. Only be sure that you do not rearrange or you do not use any other symbol apart from the symbol indicated above. The only time, okay, that you could possibly change this symbol is if this place, if you have to multiply both sides by a negative sign. Now I repeat, on no account should you change the sign except you are multiplying or dividing both sides of the equation by a negative sign. For instance, if we had to introduce a negative sign to our minus 2x, okay, now for us to get our final answer in this case, we will have to multiply both sides of the equation by minus 1, right? And the moment we do that, x will become greater than minus 2. Do you see the difference? That is the only time this sign of inequality will change in the last stage from less than to greater than. Please take note of that. Okay, so we have another problem on the board. Problem of linear inequality, and this one says solve 2 over x less than or equal to 5 over x plus 2. Like I said, solving linear inequality is as simple as solving linear equation. Okay, we have fractions here. In the case of linear equations, what did we do? When you have fractions, you get the LCM of the denominators and multiply through the equations left and right by that LCM. What is the LCM here? Simply, we have only one denominator, and that is x on both sides. So our LCM is x. So what do we do? Our LCM is x, so we multiply through by x. When we multiply through the equation by x, we have x times 2 over x is less than or equal to x times 5 over x plus x times 2. Of course, this x will cancel this x, the same goes here. So we have that 2 is less than or equal to 5 plus 2x. Okay? Now, we collect like terms, and when we do, we have that 2 minus 5 becomes less than or equal to 2x. Now 2 minus 5 will give us minus 3, right? Okay, less than or equal to 2x. Beautiful. Beautiful. Now we will have to divide both sides by 2. Okay, we will have to divide both sides by 2 in order to leave x on one side of the equation. So we have that minus 3 over 2 is less than or equal to x. Now, usually when we are solving equations, it is proper to say x equal to. So when we have to say x greater than or less than, okay, it means we will bring x to this side and do what? Take the fraction or our answer itself to the other side. And when we do, watch the open end of our symbol, okay, is towards x. So when we bring x to this side, that open end must still face x. Okay, that is the only way you will get the answer right. If you just carry x and throw it this way without taking cognizance of this very condition here, in which the open end facing x must on the facing x on the right must still face x on the left, your answer would be wrong. Okay, so ensure that the open end facing x here still faces x when you take x to the other side. Is that okay? Good. So x is greater than or equal to minus 3 over 2. Now this is an improper fraction, and what is improper is just not proper. So what do? We break it down. We break it down to mixed fraction so that 2 can divide 3, and when that happens we have a final answer as x to be greater than or equal to minus 1 whole number 1 over 2. Now that says it all. So we will look at what problem involving linear inequality and then solve something on the change of subject of formula and bring this class to a close. Now a question stares at us on the board. Just like I said earlier, if you can solve linear equations, you can solve linear inequalities. The processes are the same. The only difference is in the symbols. The inequality sign changes, okay, to a less than, a greater than, less than or equal to, greater than or equal to, and then observe the rule, okay, the rule. Observe that rule. If there is a negative sign, okay, at the end of the equation, if you have to multiply both sides of the equation by a negative sign, or you have to divide both sides of the equation by a negative sign or number, the greater than or equal to will always change. We have demonstrated those examples. We've demonstrated that in the earlier 2 examples. So stick with it and you would have no problem. Okay, so let's solve this one, just this one, okay, and I bet you can solve any other one. Now Ade bought X biros at 8 naira each and X plus 4 rulers at 20 naira each. He spent less than, okay, watch that phrase there. He spent less than 200 naira. Form an inequality, okay, for the statement and solve it. So for the biros, Ade spent, of course, for X biros, he spent 8 naira, and then for X plus 4 rulers, okay, he spent 20 naira, right? Now everything is less than 200. Everything is less than 200. That is to say that by the time we add X, okay, biros, X times 8 biros, okay, and also add it to X plus 4 times 20 rulers, everything will be less than 200. That simply says that 8x plus 20 x plus 4 is less than 200. That is our mathematical statement. Okay, the comparison has been made. So what do? We open up the bracket. We say 8x plus 20x plus 20 times 4 will give us 80 is less than 200. Again, we collect like terms. 8x plus 20x will give us 28x. To be less than, we'll move 80 to the right side so that we have 200 minus 80, and so 28x becomes less than 120. Okay, so 28x is less than 120. How did we get 120? 200 minus 80. So here we have 28x to be less than 120. What do? We divide both sides of the equation by 28, and that gives us 120. X to be less than 120 divided by 28. 4 can go here to give us 7, and 4 can go here to give us 30. So x is less than 30 over 7. If we break it down a little bit further, that would give us 4 whole number 2 over 7, right? So x is less than 4 whole number 2 over 7. Okay, that's our final answer. So the x, that is the number of biros, is, well, I don't know, maybe he broke some on the way. That's why we have the fraction there. Okay, but that's the final answer, and it's that simple. Now we will solve a problem on change of subject formula and get the class done with.